Okay, so this is because of time, we're going to move on quickly to the functions. For the next part, we're going to talk about another topic, very important topic, that's called functions. So for functions, they have specific syntax. Usually, we need to use function to define a function. We're also going to learn how to return a value from a function. And sometimes we need to check the parameter or called argument conditions with the stop if not in functions. So let's look at an example, the function syntax. So usually the functions start with the function name that you would like to call this new function. For example, things like we learned function, useful function like any and all, these are already built-in function in R. Sometimes if you would like to have specific task, you want to call it, for example, we would like to have a function that converts temperatures from Fahrenheit to Kelvin. You could call it Fahrenheit to Kelvin. That means what the function does. So my function is going to usually a brief of what the function does, followed by assignment operator, and then use the function. Inside this function, this is going to be the parameters. You could separate the parameters, for example, parameter 1, parameter 2 by comma if you wish to do so. And then you use, again, the curly brackets to define the action. You could also incorporate the for loop. You could incorporate the if-else conditions like we talked about. Let's just briefly talk about, let's say it perform certain kind of actions. Perform action. And then after that, you could return value. So we're going to modify this function in order to do a specific task. Our task is to convert temperature in Fahrenheit to Kelvin. So I'm going to rename my function, name Fahrenheit, keep the first 4 letters from Fahrenheit, and then to Kelvin. And then I only need one parameter, so I'm going to call it temperature or temp. The action I'm going to do is to create a Kelvin variable from my input value called the temp. So what I'm going to do, take my temp, subtract 32. This is a formula to convert Fahrenheit to Kelvin. It's kind of like a function. Take your input, subtract 32, and then multiply by 5/9, 5/9. And then after that, we're going to add 273 and 15/100. This is was a little disruption for the in-person students. I'm going to quickly see. Cancel shutdown, and then see if I can restart the system.
You saw it. I thought like your circuit breaker.
Spotlight on.
Okay.
Standard mode.
But she lost power.
There are, I didn't know which mode was chosen. Recording studio mode. Let's just choose. And you're unable to see that. Wonderful. Okay, we're back to normal. So this is action. Followed by action, we usually return our value. Return Kelvin. So let's do a quick check. Review. This is the function I'm going to create. Some new name. Give it a name that's easy to understand what the function does. An assignment operator. Use function. This is a function called function. And then inside the parentheses, after a function, there is always parentheses. This inside will be the argument or parameters you would like to feed into this called Fahrenheit to Kelvin function. And then once you supply this input, you take the input, subtract 32, multiply. This is the formula to convert a Fahrenheit to a Kelvin. You type up the formula using R and assign that to a new variable called Kelvin. And the output will be this Kelvin variable or object. You're going to return that. So let's execute our function. You can see that in your environment, there will be a new function you have defined. And if you want to use this function, let's try that. What is the temperature in Kelvin for the freezing point of water? We all know that the freezing point of water in Fahrenheit is 32. So we supply our function name and then change the input to 32. This will be a typical usage of your function to get to the freezing point of water. Similarly, we can also change the number to get the boiling point of water in Kelvin. The boiling point of water in Fahrenheit is 212. So we supply that as parameter into our new created function as the input, and that will return you the boiling point of water in Kelvin. So now I invite you to work on a little challenge problem to write a function called a Kelvin to Celsius. Note that to convert Kelvin to Celsius, you will subtract 273 and 1500. So this is how you calculate Kelvin. From Kelvin to Celsius, you're going to only have to subtract 273 and 1500. Very good. So let's take a look at any questions. All right. All right, let's work on this challenging problem together. So this new function we're going to create is called Kelvin. Convert Kelvin to Celsius. So we're going to call this function name Kelvin to Celsius. And then we're going to use function to define the parameters. Let's use temp again. So given a number in Kelvin, in order to calculate Celsius, it's going to be equal to the input subtract 273 and 1500ths. And then similarly, after we perform the action, we're going to return the output. All right, so this will be our solution. If you're providing, let's say, Kelvin in using this input, let's test our result. Take our function name, supply an input, and then it should return you the number of, this is the boiling temperature in Celsius. All right. So next we're going to talk about combining functions. So for example, since we have created two functions, one function is Fahrenheit to Kelvin, and another function based on Kelvin, it's going to convert that again to Celsius. So let's try this. See if you can define the function to convert directly from Fahrenheit to Celsius. So provide the input temp and then convert from Fahrenheit to Celsius. You can either combine these two functions. Alternatively, you could define this new function from scratch if you prefer. if you have finished, you could put your green sticker there. Wonderful. So we can work on this together. Our last function is called Fahrenheit to Celsius. So we put the name here. That's a new function we're going to create. And after that, we use function to define the arguments or parameters. What we are doing right here is that what you can do is that you can create a little temporary output to store the Fahrenheit to Kelvin, the temperature in Kelvin. So use the first function we have created. To take your input and create and generate a temporary output in Kelvin from your input temp. And the next step will be the result, or you could call it temperature in Celsius. And then the next step will be using the second function you did. This is one solution to combine the two functions together. And again, here the input is going to be the output of previous step. So we perform two actions in sequential order, and after that, we return the result. Fahrenheit to Celsius. So we could test this one. We could execute this one, and then we could also test, for example, 212. That's the boiling temperature in Fahrenheit, and then, excuse me, I'll do that. I'm going to take my function I have created to test my function, see if it works. 200 volts. I should return 100 if you're coding correctly. Yes, there we go, 100. Alternatively, some of you might be doing the other way by just taking, for example, just taking Celsius is equal to the temperature subtract 32 and parentheses multiply by 5/9. This is another approach if you prefer that way. Solution 2 will be, let's take this one and make modification. We only need one line because you're defining that from scratch. Oops. I was going to use this part of code. There you go. This is another way to generate your results. Subtract 32 and then multiply by 5/9. Let's do it again. All right. So always testing your function and by provide a valid input. So next topic is called defensive programming. It's going to be considered checking the conditions of your parameters. This is very useful because sometimes if you provide invalid arguments into the function, that will give you an error message and give you hints on where you have done wrong in inputting the parameters for the function. So we're going to talking about checking conditions, condition for the argument using the stop if not. So let's say for this Fahrenheit to Kelvin, for this original function I have created, if the input is not a numerical data type, I want to stop. So in this case, I could use stop if not function to check on whether this input is a numerical data type. So I'm going to copy what I had before, this function, and then I'm going to add the checking conditions to it. This time I'm adding checking condition. Right here, there are two ways to check the checking condition. We could first use the if and stop if condition. So if we use the exclamation mark to represent not. If it's not a numerical data type for this input, I'm going to perform the action, curly brackets called a stop function. And then I'm going to print out a message called a temp must be a numeric vector. And then the rest of the code I do not change. This is one way. Alternatively, this if and stop could be replaced by stop if not. So that means, let's make a copy of that, add it this stop if not. So I'm going to say, remove this if, and then call it stop if not. That is a function. Inside the stop if not, it's going to be a logical statement. So is numeric is going to perform a logical operation to check the input whether it's a numerical or not. So if it's a numerical, it's going to return you a valid output. So let's try this. Stop if not, that means if this is false, that means temp is not a numerical data type. If this is not, I'm going to stop. Okay, let's guess what's going to happen with my Fahrenheit to Kelvin if I supply something that is not a numerical data type. I could do, I could use my function. How do you test it? You type your function name and then supply something. I could do a logical input that's not a numerical data type. So this one will give you a message. That means the checking condition is not true. Similarly, if you have factor data type, let's say we made a numerical data as a factor data type, it will give you the same error message because this input is not a numerical anymore. So any questions about checking conditions using stop if not? All right. Our last challenging problem is going to use this defensive programming stop if not or if stop condition to make a defensive programming to ensure the last function we built from Fahrenheit to Celsius can give you an error message if the argument is not valid. Yes, I think what happened is they remove the current and move to the previous. That's changed. Yes. I can clear it out. I got some. Got a solution from chat box about a previous challenging problem. All right, let's work on this together. We're adding a stopping stop if not condition to check whether the input is valid or not to our previous function. So we get our function which is working, and then we add stop if not. We can add this condition before the first action, and that will work. If you're still supplying a valid number, that will give you the correct input, correct output. If not, let's say we make changes on that. That will give you an error message that says the input is not a numerical. All right. The last little thing I would like to mention is that to use the source function to call on the function you have generated. So the source, inside the source function, this is going to be the path and file name of your R function file. So if you have called source, for example, this name, this file name is called day2. let's say if we have a new file and save that as function test. So let's say we have done some function already. And another day, you would like to use those functions that you have created. You can use source to put the directory. Let's get our working directory to find where my path is located. All right. I think I could directly call that source day2 because it's already in the correct. Let's see if they work. Okay, there is one line of coding that that has some error message on purpose, so we could delete that. We'll search for -1, 2, 3. But this one doesn't work, so I'm going to comment that out. And okay, so how about let's save our function into a specifically file. So if you're using function, using source file, everything in that source file has to be working. Let's call it function. And now, if we're to source our functions created, okay, there was an error message because we tested some examples that are not working. We need to remove everything that's not working. So this is one thing we need to keep in mind. If you're going to source the function file, everything in that file has to be working. And then once you source the function file, you can use the function you have created from that file. Let's say Fahrenheit to Celsius. And then we could supply a valid input and directly use the function. This is the last thing we will talk about. We talked about. So thanks to everyone for joining us today. To give you a recap, today we talk about subsetting data set. We also talk about control flow, things like if, an else, or for loop. We talk about creating publication plot, and vectorization and functions. Function can be really powerful when you want to create your own specific functions to use for your data analysis purpose.